system. And so in the packet that I gave you, I made this flip book for you, and we're going to take a look at the first half of it today, and then we'll finish off with the second half next week. So as we study our solar system, let's just talk for a moment about why it's called the solar system. A system means moving parts that all work together, and solar means the sun. So we call our solar system the solar system because it has the sun, solar, in the middle, and it's a system of moving parts that all move around something. Now, when we look at our solar system, the solar system is divided basically up into two sections. We have some inner planets that are closest to the sun, and they are all made of a rocky material, so you could actually land a spaceship on them because they're made of rock. Then we have this asteroid belt, which is a bunch of space rocks, tiny little and medium and large space rocks that orbit around the sun. And then the second half of our solar system are the outer planets on the outside of the asteroid belt. And these are called gas giants because they're made of gas. You couldn't actually land on them, and they're giant. So today we're going to focus on just those inner planets. So if you lift up your sun flap, you'll see that the first flap underneath that is the planet Mercury. And looking at our planets in order from the sun, Mercury is the first planet in order from the sun. Mercury does not have an atmosphere, and so there's nothing to help it maintain regular temperatures. Instead, it's freezing cold, negative 290 degrees Fahrenheit on the side that's facing away from the sun, and then it's crazy hot on the side that's facing the sun, 800 degrees Fahrenheit. Just like all of our other rocky planets we're going to study today, this planet does not have any rings. All of our planets today won't have any rings. It's not until we're going to get to the gas giants and the outer planets that we'll find rings. Mercury does not have any moons. And yes, like all our other rocky inner planets, it is a solid surface you could land on. The diameter of Mercury refers to how far across it is the middle. So what is the distance around the equator of that planet? And Mercury is 3,032 miles wide at its equator. Now that might sound like a lot, but let's go ahead and see how it compares to the other planets. The four planets we're talking about today, Mercury, Venus, Earth, and Mars, of those, Mercury is the smallest, and that makes it the smallest planet out of all of them. Let's compare them with the gas giants in there too. So now that we add the gas giants in there, you can see that Mercury is really puny. Space missions to Mercury, we have successfully sent 2 probes out to Mercury, Mariner 10 and Messenger. On Mercury, a day lasts 59 days. So one Earth day, again, is 24 hours. That's how long it takes for our planet to make one full rotation on its axis. For Mercury, it takes 59 days for it to be one day on Mercury. A length of a year is shorter than the Earth. It takes only 88 days for Mercury to go all the way around the sun back to its starting point. And that's because it's so close to the sun that it takes such a short time. So it does have the shortest year out of all of the planets because it's so close to the sun, it doesn't have to travel as far to get all the way around it. And of course, Mercury is one of our inner planets. Moving on, let's take a look at the next planet. If you flip up your Mercury flap, the next one you're going to see is Venus. And Venus, looking at it in order, is the second planet from the sun. Venus has a very, very thick atmosphere. So here's a computer generated image of what it would look like on the planet Venus. And because of that really thick atmosphere, thick layer of gases that surround the planet, it actually has the hottest temperature of any of our planets. It burns bright, partly because of the gases that are in that atmosphere and how thick it is. So that thick atmosphere equals it being the hottest planet at 864 degrees Fahrenheit. Now, Venus, like all our other rocky inner planets, does not have any rings. It does not have any moons. And yes, it is a solid surface. And again, here's a computer-generated image of what it might look like on the surface of Venus. The diameter of Venus is pretty close to Earth, 7,520 miles, so just a little bit smaller than Earth. Out of all of these inner planets, Earth is the largest. Venus is the second largest, just a little bit smaller than Earth. And in comparison to all of our planets, you can see it's, like I said, a little bit smaller than Earth, but much smaller than our gas giants. Missions to Venus, because it's so close to us, we have been able to send a number of space probes out to explore it and take pictures of it. So we have 20 different space missions that we've sent out there to Venus. None of them have yet landed on it or gotten through the Earth's the atmosphere because it's so hot, but we've gotten pictures from flybys where we drive, like our probes go past it. Venus, again, is kind of similar to Earth in terms of its size and also how it moves. It does take 243 Earth days for Venus to make one full rotation. So it takes 243 days, Earth days, for this thing to have one day all the way around. Its year is similar to Earth's, though. 224 days is how long a Venus year lasts. So that's how long it takes for Venus to go all the way around the sun back to its starting point. And since Venus is so bright in the sky and it's right next to Earth, standing here on Earth, as Venus makes its revolution around the sun, we actually do see phases of Venus similar to we do see phases of the moon, where we can sometimes not see all of the lighted part of Venus that's facing the sun. And of course, Venus is, just like the rest of them today, an inner planet. Let's look at Earth. I'm not going to spend a lot of time on this planet because I know you know about her. Obviously, she is the 3rd planet from the sun. Temperatures on Earth are comfortable for humans to live. The coldest temperature was negative 114 degrees Fahrenheit in Antarctica, and the hottest temperature ever recorded on Earth in the Sahara Desert was 116 degrees Fahrenheit. And our atmosphere, those layers of gases that surround the Earth's surface, are part of what helps us to keep those temperatures comfortable, not too hot and not too cool because of that atmosphere. Of course, rings are 0 for Earth. The Earth does have one moon, and obviously it's a solid surface. Yes, it's a solid surface. The diameter of Earth is 7,918 miles, so across the equator, that's how far you would have to travel around the whole equator. So as I said, it is the largest of the inner planets here, but it is pretty small in comparison to our gas giants. In terms of space missions, this is Earth, so we don't really have to take a space mission to travel it. So this NA here stands for not applicable, which just means that that information isn't really appropriate for talking about Earth. We don't have to take a mission to go see it. A length of a day we already know is 24 hours, and again, that refers to our rotation, turning on our axis. And the length of a year is based on our orbit or revolution around the sun, which is 365 days and then 1/4 of another day. That's why we have our leap year. And of course, it's an inner planet. The last planet we're going to look at today is Mars. And so in order from the sun, 1, 2, 3, 4, it's our 4th planet. The temperature on Mars is not horribly too extreme. Still not very comfortable for human life here. But Mars does have a thin atmosphere, definitely not anywhere near as thick as Earth's or at all like Venus's, but it's thin enough that our temperature doesn't get too extremely hot. But it can get pretty cold on the part that's facing away from the sun. So negative 195 degrees Fahrenheit at its coldest to a range of 70 degrees Fahrenheit, which is pretty comfortable at its hottest. Mars does not have any rings, but it does actually have 2 moons. Phobos and Deimos are the names of those 2 moons. So if you were standing on the surface of Mars and looking up in the sky, you'd actually have 2 moons shining up there in the sky. And yes, it is a solid surface. Now, the diameter of Mars is 4,212 miles, so significantly smaller than Earth and Venus, but still larger than Mercury, but looks pretty puny compared to the rest of our planets. Because Mars is so close to us, just like Venus, we've had a lot of space missions. There's been 16 of them, and here's some of them, not all just from the United States, but other countries as well. And 16 have been successful. There is some that that failed or got destroyed during launches. But because we have been able to send so many missions there, we've been able to land on the surface of Mars because of its comfortable temperature. And so we currently have some robots up there that are currently taking pictures of Mars and sending them back. So we have a lot of amazing footage of Mars. The length of a day there is just a little bit longer than an Earth day. So it takes 24 hours and then another 40 minutes for it to rotate. I'm sorry, I should have made that line a little longer for you. Squeeze it in there. And then the length of a year, since Mars is farther away from the sun than Earth, it takes longer than the Earth to get around the sun. So while the Earth takes 365 days, since Mars is farther out, it takes even longer. So it takes 687 days. So almost, but not quite double the amount of time as Earth to get around the sun. And of course, it is an inner planet. The last thing we'll look at today is the asteroid belt. And as I mentioned at the beginning here, the asteroid belt is this collection of space rocks and debris that also orbit the sun. So we have our inner planets, and then they're separated by the asteroid belt from the outer planets. So to get an idea of how big this thing is, here is Mars orbiting around. We've got our sun, and then Mercury, and then Venus and Earth and Mars. And then here is our asteroid belt, and it is 93 million miles thick. So that is a lot of space rocks. It is literally home to millions of asteroids, as you can see by these two pictures here. Millions of asteroids, more than we can possibly count. Of those asteroids, the two largest that I want to point out to you are Ceres and Vesta. Ceres and Vesta. And Ceres is actually large enough that it's considered what we call a dwarf planet. Not big enough to be a true planet, but significant enough that it gets this term dwarf planet. So comparing, here's Earth's moon, here's Pluto, which is even smaller than Earth's moon. And you might know that Pluto is now considered a dwarf planet instead of a regular planet because it's so small. And Ceres is in that same category as Pluto. It's pretty skinny. And then Vesta is another large asteroid. And then two more. We have Pallas, 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 and Hygiea, Hygiea, Hygiea. And of course, as we mentioned earlier, the asteroid belt is located in between Mars and Jupiter, and there's really quite a far distance between those. That's all.